if you ever miss and are looking, yes. If you come to classwork when you're over here, these weekly calendars, I got next week's post, but here's this week. Like, let's say one of these days that you missed. Every day this week, I posted a video on what we did. So, like, Monday was graphing, Tuesday was substitution, Wednesday was elimination. Yesterday, we went back to substitution and graphing. So if you missed either of those and you want everything in one, that's the way to go. And then today, we're going to double back on Wednesday, because that was a little longer, a chunkier of a lesson. Just going to do some odds, get you feeling good on that. And then that should give you a real good roll moving into Monday when we review before we do our quiz. So today, though, I am going to be in the practice here on page 10. And like I said, I'm going to knock through some odds. I'm not going to go crazy with this. But I do want to make sure I hit up on some of the highlights to make sure that whether it's your first or second time seeing this, you're going to be good. So I'm going to start at 1 because those are the ones that we hope for. Yeah, just in regular practice, you will be able to use your notes as you always do when we get to the quiz, so make sure those are up to date. We're always hoping on elimination that I can add down right away. And if I'm not sure sometime, and I'm like, oh, I'm not sure. Oh, of course, oh, that's right, I gave my notes. Okay, I'll come back to that. We want to check first to see, hey, if I add down right away, will I get lucky enough that one of my variables will cancel out, and then I can just go to work on this. There's the notes that I was looking for. So, just so we have a reference, because again, the notes are better than for something just for Hardy to be taking up your time. So, okay, can I eliminate a variable by just adding down? Yep, this time I can. And I keep adding down. 5 minus 3 or 5 negative 3. 3 and negative 9 is negative 6. And all of a sudden I got a one-step equation. I like one-step equations. They're pretty easy. And very quickly, I have an answer already. Notice I said an answer, not the answer. Because now my job is to substitute my answer back into either one of the equations so I can get an answer. So here's what I'm going to do. I'm going to take that top equation, and I'm going to start copying it until I get to the variable that I solved for. I solved for y. I know that y is negative 3. So I'm going to substitute that in. Everything else is the same. And so once I substitute that in, we'll do 5 times negative 3. We'll simplify that. And now we're just back to regular old two-step equation. And divide by 9. Now, I prefer to see it as a coordinate point like this because x always comes before y. But if for some reason you forget that and you just So here's the thing though. Every time it's not going to go away when I add down. Sometimes, if I move down a little further, it may look like they're going to. If I look at number 5, I might get suckered into thinking, oh, the y's are going to cancel. But they're the same sign. Negative 6 plus negative 6 does not cancel. You're like, crap. Well, these don't cancel either. So you're like, okay, what can I do to fix it? We talked before about how you can look at the smaller number and say, hey, can I multiply 4 by something to get 7? No, not really. Well, these are both 6. But, okay. But the key here is when we do this, we need to make sure one's positive and one's negative. So if I need that to be the case, if I just multiply this bottom one, we'll say by negative 1, that negative 1 goes to all of these. and changes all of their signs. Oops, that's my equal sign. I was looking at that for a minute. I was like, wait a minute. Yeah, I don't know why the equals part disappeared. That was kind of weird. If it was -2, that would not make much sense. And then I'm going to leave the top one alone. So sometimes we may have to multiply one of our equations. But that's just so we can make sure that one of the variables goes away. 7 minus 4, or 7 plus -4 is 3. 8 minus 2 is 6. We divide that out. We got our first answer. So once that first answer is set, and it doesn't matter if it's x or y, the first time we got y first, this time we got x, I'm going to go ahead and keep using that top equation each time. And so I start writing until I get to the variable that I solved for just now. So we're going to replace the x with the value I found. Get that in there. And we're just working on getting that y term by itself. And I know I say this a lot, but I keep seeing it, so I'm going to keep saying it. This is not add 6, add 6. That's -6 times y. So we got to do a divide on that one. Okay. So this is why elimination got its own day instead of splitting like we did with graphing and substitution. First one, I didn't have to do anything really. I just added down. This one, I had to multiply one of my equations by something. Let's see what else might throw a little curveball in here on stuff. Because elimination's kind of shifty when it comes to that. It kind of changes things up on us. So let's see. Come down a little bit further here. Because I'm noticing with all of these, I'm always going to have one equation I can multiply by. So I'm not going to do 7, but I'm just going to make mention of one thing. So like here, for instance, I'm like, well, 3 plus 6 doesn't cancel, and 1 plus 10 doesn't cancel. But 3 to get to 6, I can do that. I can just multiply this top one by -2. Because that's going to give me -6x and +6x. They're going to cancel. So you'll always have one of your variables probably that you can multiply one of them by a number and make it where you can cancel a variable. But that's not even a guarantee. Let me throw one more your way. Number 11. Now this is about as bad as it gets. Because I'm like, okay, 2 times what to get me to 9? Well, that didn't work. Okay, that's going to be a decimal. 4 times what to get to 5? That doesn't work. That gets me a decimal. So now I pull my notes back out and I go, okay, let's find one that's similar. This one's kind of similar. So I had 5 and 2, and it looks like I just switched the coefficients around. So let's see if that works here. So I'm going to do 9 up here. And I'm going to do 2 down here. So I literally just switched those. Now in the example, I had to multiply by a negative, but Hardy didn't this time. So is he just getting old and senile, or did he mean to do it actually this time? I actually meant to. Because here, if I'd have kept that +5, +10 and +10, that doesn't cancel. One of them has to be negative. Well, this already has a negative. So when I multiply through, that should fix the problem for me. So let's see. Multiply through 9. Friday afternoon. Need a little help on my whoops, hang on a minute here. All right, 144. Down here, we'll distribute the 2 through negative 18x, negative 10y, positive 40. So by multiplying both of them, now I was able to get rid of the x. And then we're just going to deal with y here. That a little better. So when I add down, x's go away. We're going to have, I think that's negative 46. Yeah. Negative 46y. Again, don't be afraid to go to the calculator with your coefficients. 184, and now we cross our fingers. When we divide by negative 46, do we get a whole number? We do, negative 4. And make sure you're focused in and remember, and all of a sudden this doesn't turn into x. I've seen that happen to people too. And then they're like, what the heck happened? I'm like, variable got switched. You're like, oh. So again, for our final trick, back to the top equation. Keep writing until you get to the variable that you know. Once you do, variable out, number in, negative times negative is positive. Lots of little things. Opposite of adding 16. Yes, there is still something there on the other side. It's not just gone. It's still 0. And we can divide 0 by something. We just get 0. Okay, so elimination. 3 options. Add straight down, we hope. Multiply one equation to get a variable to go away. Multiply both equations. And you've got examples right next to the ones you're looking at. The last thing I'm going to talk about, and that's going to wrap us up with plenty of time to play here. We're going to look at the applications again and how they set up. Because I know that's always a tricky thing. Say they open the door and they don't close it. So I want to play with a couple of these. I'm just looking to see what ones I have. Okay. 13 and 15 should get us in good shape here. Might even do 13. No, I'll do 13 and 15. All right. So, Deshaun and Stephanie are selling cookie dough for a school fundraiser. Customers can buy packages of sugar cookie dough and packages of oatmeal cookie dough. Okay. One of the things we saw the other day when we were doing these is we want to make sure that we define our variables. So, I'm going to go with S for sugar cookies. And, do I want to do O? O looks like 0. I'm going to do C instead. So C for oatmeal cookies. Now we're hoping sometimes you're going to get your pieces from different sentences. So like you might find money in one sentence and money somewhere else, and quantity, and you have to put them together. Or sometimes we get fortunate and everything we need for one of our equations is in one sentence. And that's the way this one sets up. So here we go. Deshaun sold 8 packages of sugar cookie dough, so 8S, and 12 packages of oatmeal cookie dough, 12C, for a total of $324. Okay, that's pretty straightforward. I like this. Then we go to the next sentence. Stephanie sold 9 packages of sugar cookie dough and 6 packages of oatmeal cookie dough for a total of $237. So those two sentences gave me my two equations, like as straightforward as can be. But now I need to figure out how much does one package of each cost. So I got to go back to what I was just doing. Unfortunately, I cannot add down. That is not going to work on this one. I cannot multiply 8 by something to get 9, even though you could do the switcheroo. You could. What can I multiply 6 by to get to 12? 2. And since these are both positive, I'm going to multiply by -2 because that's going to fix my positive-negative issue. And I know it's not always the most fun, or you might even think time-worthy to rewrite this, but when you're trying to figure out what work you've done already, it's going to be worth your while to do that. 237 times negative, 237 times negative 2, -474. I can see that my C's are going to cancel. There they go. -10s equals -150. Well, it looks like 105 equals 150s. Okay. Divide by -10, because we shouldn't be getting decimals for these. So your sugar cookie dough is $15 a package. Okay, got it. But I still need to know how much the oatmeal cookies cost. So again, just like we have before, I can go back to either of the original equations. I'll even call this 1, and I'm going to do this for 2. I'm going to retake this blue equation here, and I'm going to plug in the s when I get to it. So 8 times 15, because that's what the sugar cookies cost, plus 12c is 324. I'm going to get away from my arrow here. So I multiply the 8 and the 15. And now we're back at a regular old two-step equation like we're used to. We're going to minus our 120 over. And again, we're hoping this goes in nice, and it does. With labels. I was nice enough, I'm going to peek and make sure I'm telling the truth. Okay, I want to make sure I was telling the truth. All the application problems are going to set up that way. You're not going to have to do ones that you had to piece them together like we did the other day. These are going to be straight. Here's a sentence, here's an equation. Here's a sentence, here's an equation. And then go solve them. So the best thing that you can do today is, I'm looking through, 17. If you do the evens, that's 8 problems. If you do those, you are going to be well set up to breeze through this review on Monday and breeze through that quiz on Tuesday. Some of you are going to keep not doing the practice.